Good morning, everybody. Welcome to class this morning. I just want to take a moment here and thank you for tuning in and watching. Hope that you're still getting something out of these live streams, that they prove to be valuable to you. But this week we're talking about value methods. You know, we had a 2-week module last time with module 5. Just because, you know, we're starting to wrap our heads around something brand new that we're dealing with. But with module 6 here, we're back to another 1-week module, which is value methods. Because we really already know the foundation of writing a method, because we wrote some void methods. We started writing void methods a couple weeks ago. And our value methods aren't really that different from our void methods. There are some differences that we'll get into about what we can do with them and how we use them. And this is really where we start to get into some more valuable, more flexible type of method writing. It's with our value methods. So what we're going to do today is we're going to look at value methods, but we're also going to look at something a little bit different when we get into some of our demonstrations today, because it's something that I don't really teach directly in the class, but I do like to teach you how to write your own objects and how to create a more object-oriented program. And it's at this point where we start to do that. And so when we get into writing our value methods, we'll scope our value methods a little bit differently, just to kind of practice and do some different things. And look at writing objects with our new methods so that we can have some nicer programs. But as we get started here talking about value methods, I think it's important for us to kind of go back and have a look at what we know so far. So previously, you know, a couple modules ago, we started using void methods to modularize our code into different chunks. You know, we wrote out the public static void, whatever, and then because it's a void method, we printed whatever statements out of there that we wanted. You know, we've been practicing that for a couple weeks now. As methods are invoked, code is executed within them. So remember that it's not just enough to write the method, but we also have to invoke or call the method inside of our main method so that our interpreter knows, or really any method, we have to invoke our method somewhere. We have to invoke at least one method inside of our main methods if we choose to chain other methods inside of the other You guys know. We've been doing it for weeks now. It's all good. We just have to invoke these methods when we need to use them so that we can use them. But one of the things that makes our void methods sort of troubling, sort of unuseful, was the way we would have to work with them. If you'll remember, we had to, if we were going to take data from one method and pass it through to another method, we'd have to call that second method inside of that previous method and pass the data through as an argument. And at the heart of code modularity, with the spirit of wanting modular code, interconnecting all of our methods like that, not particularly useful, not particularly helpful. It doesn't really modularize our code because we have these interconnected methods that where one can't work without another. And that's just by the nature of the void method. But what if we want to get that real modularity to where we can write a method and then maybe pass the results of that method into a variable, or use the execution of that method to get results and use the results as an argument in another method? Well, that's where our value methods come in. Our value methods are primarily different from our void methods in two specific ways. One, they declare the type of the return value. We call this the return type. So like when we declare a variable, we have an integer variable, we have a string variable, we have a double variable, so on and so forth. Whatever value we're returning out of our value method is typed to that data type. So if we're returning a string, it is a string value method. If we're returning a integer, it's an integer value method. If we're returning a double, it's a double value method, so on and so forth. And these value methods have to utilize a return statement to provide a return value. So when we put that all together, what we have ends up looking something like this. Right? So in this example here, we have pi times radius squared, right? So this is a little area of a circle value method here. So the important things for us to look at when we're looking at this value method is, one, we look at the declaration in the header of our method. And we're still using public static scoping here. But now instead of void, we've added our double data type. Because what we're returning here is result, and result is a double variable. So whatever value that we're returning out of our method in a value method, whatever data type of that value that we're returning, that is what we put here. So if it's an integer, this would be int. If it's a string, it'd be string. Boolean, Boolean, so on and so forth. And then the rest of it is relatively normal, right? Relatively what we're used to in terms of, declaring void methods. Right? We have this calculate area. We have an argument of a radius value that we're bringing in from another source. And then instead of printing a result, or initializing another function here at the end, invoking another function here at the end, we are returning our result. And so this is key, right? This is what we want to do. When we're ending a value method, we end it with the return statement. And once that return runs, it ends the execution of the method. So we'll talk about dead code here in just a little bit. Anything that's after a return statement in a method, anything that's after a return statement that is runnable in a method, is what we call dead code, because it'll never be reached. But let's go ahead and kind of write this into our into a little sample program here as we kind of work along. We'll just take this exact thing here and write it over inside a new REPL. So I've got a new REPL here. Whoops. Wrong screen. Got this new REPL here, and I want to write this void, or this value method that we just saw on our slide on this method. Now we're going to start out by doing this in a way that, you know, we'll look at a slide that talks about this a little later on. But whenever we're writing value methods, one of the things that we get to do is we get to write what we call a stub. So we can write in order to have a functional value statement or value method, it has to have that return, right? So if I want to write an empty void method, I can, right? Like I can add a public static void empty, and I can write that just fine, and that's going to let me still execute my code. But one of the issues of utilizing a value method, right? So if we add our value method for our area of a circle, public static double calculate area, and we'll add our double radius argument here. If we leave that empty and go on to work on something, well, that's going to throw us an error. And we can see the error that it says here, missing return statement. We need a return statement. So if we want to write an empty return statement, or an empty value method that we're going to go back and work with later, we have to write a return statement with a returned value. So in this instance, since it is a double, I can write return 0.0. And now I can kind of have this here, work around this and go back to it later. My program's going to execute just fine now, because it is expecting this return statement at the bottom or at the end of my method somewhere. And we call this a stub. This is a stub where we have our header for our method and the return statement in our value method. We call this a stub. And so let's change our stub here. We can keep our return statement. We can just change what we'll be returning here in a few minutes. And let's write the code that we intended to write in it, which was creating a double variable that we were going to call result, and setting that equal to math.py times, and you know what is it? Let's check our math library right quick. Because I think it'd probably be better just to use an exponent. Is it? Yeah, pow. We'll use math.pow instead of radius squared. Or radius. In our example, it was radius times radius. We'll use math.pow to do the radius squared. So this will be math.pow radius 2. And that gets us the result that we're looking for. So now we can return result. So now we notice here what we have is our value method, and it's returning. We're not printing out of this method. So if I invoke this method inside of our main method, the way that we would invoke a void method, maybe something like calculate area 12 as our argument value, Well, that's going to give us nothing. Because a return and a print are two different things. A return just takes a value and passes it back. You still have to tell your program what you want to do with the value that's returned. So if I wanted to print this out to my main method, I would have to wrap it in a system.out.println statement. And put that in between a set of parentheses. So now that'll return the result, put it in place of where we have our method invocation here, and print it out accordingly. So we can run that now and see we get 452.38.934.211, so on and so forth, right? And so now we see that method that we looked at on our previous slide, on this slide, we see that method in action. So we can see how that works now. We can see a couple of the idiosyncrasies about value methods versus void methods. Now when we're returning this value, one of the important things to remember here is that the type of expression in the return statement must match the return type of the method. Can't stress this to you enough. Like, this is a place where I've seen students over and over and over again get kind of confused about what they're doing and try to return a different data type value that's going to be different than what is found in the method header when you declare that method. That's a mismatch. That's going to throw an error. That's going to break your program every time. You want to make sure that the value being output is the exact same type as the value that you're calling for. Because essentially what you're doing here is you're creating expectations, which is an interesting, which is a way to look at this, right? You are creating expectations. You have in this method setup, you're telling the interpreter, hey, look for a double, or hey, look for a string, or hey, look for an integer, because that's what I'm putting that you're going to find in the header of this method that we're writing here, of my value method. This is the type of value that you're going to find. And so it's going to be the type of value that it's going to, you're going to expect to see on the other end. Right, like imagine, if you will, like we can put this in a bit of a different perspective. Imagine, if you will, you get told in the morning, oh yeah, we're going to have steak for dinner. We're going to have a nice big steak, maybe a potato, or whatever your favorite is. Dinner tonight's going to be whatever your favorite is. And so you go throughout the day, all day long, you have this expectation of that steak. When I get home this evening, I'm going to get a steak. Or I'm going to get my favorite, lasagna or chicken or whatever it is. Then you get home, and there's a salad on the table, just a salad, or something that you weren't really expecting. And so that's the kind of thing that we're talking about here. We're creating expectations. We're telling our interpreter that it's going to get a steak. And so when it gets to that return statement, it's expecting a steak. But if you try to give it a salad, if you try to give it a Hot Pocket or whatever, it's going to be like, whoa, 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 what is this? What is this? This is not what I was looking for. You're creating these expectations. You're making a promise. when you add the data type to that header of your method. So if you're declaring that, the return type is going to be a double, when it gets to that return statement, it's going to be expecting a double. If you declare that return type is a string, when it gets to that return statement, it better be getting a string. If you declare that return type is going to be an integer, when it gets to that return statement, you better be giving it an integer, because that's what it's looking for. That's what it's expecting. If it doesn't get what it's expecting, it's going to get confused. It's going to get upset. It's going to throw an error, which is less than ideal. Now, most of the time, your value methods are only going to have one return statement in it. The only real change in that is going to be if you have a conditional statement in there. In a conditional statement, where each of the conditions are going to output something, each condition has to have a return statement. Now, only one of those return statements will be executed, because as we've talked about before when we talked about conditional statements, that's how conditions work. Right? If we chain several conditions together, each of those conditions has a return statement to run on our output. In the event that we run this output and we get this return method, or in the event that we run this condition and one of these conditions prove to be true, it needs to have a return statement. So what I'd like to do here is I'd like to write a little function that has both of these in it for you, so you can see this executed. So we'll head back to our REPL here and get it going. So what I'm going to do is I'm just going to, for our purposes right now, and we'll probably come back to this a little later, I'm just going to comment out this function here for the time being. So we can kind of keep our main method clean for right now. We'll remove that from here. So we can write like an even odd checker, right? So let's do that. Let's make ourselves a public static string even odd, and we'll give it an argument of an integer int x. Now, so we've given this a string. And we can, for the time being, we can just say return to complete our stub. So now we have a nice completed stub. So if we go back up here and run it, we won't get an error. So we'll write ourselves some code inside of here. We're going to take an integer value into this, and we're going to print out even or odd based on whether the number is even or odd. So we'll say if x modulo 2 equals 0, then we are going to return even. Else, we are going to return odd. So now we can see here just a little bit of a different example where we're checking to see if a number is even or odd. Now remember, when it comes to this value here, that's our return data type value. So it depends on what we're returning. Even though we're doing math with integers and we're bringing an integer in, that doesn't matter. What matters is the type of value that we're returning. In this case, it's either a string of even or a string of odd. So it's going to be a string. So if we run even odd on an integer like 6, we should expect to get even printed out to our console. Even. There she is. We put an odd number in there. We should expect to get odd printed out to our console. And so this is the kind of stuff that we're looking for with our value methods. So this is an example of using a conditional statement. Now we're having one return for each part of our condition, but it's only going to return one of those values, right? You can't return more than one thing from a method. You can only return one. So you're either going to have one final return statement, or you're going to have one return statement in each part of a conditional statement. Here's another example of return statements. And this was kind of interesting. It's an absolute value method here, which is pretty cool. So we're saying if x is less than if x is less than 0, we're going to return negative x, which is like a shorthand of saying -1 times x. So if it's less than 0, i.e. a negative number, you're going to multiply it by a -1, which is going to make it a positive number. Or else you're just going to return the number if it's greater than 0 or more. Which is pretty cool. You know, that's an absolute value function. You know, if you're taking the absolute value is a positive number, whether it's positive or whether your input is positive or negative, it's going to output the positive version of that. That was something that we were looking at previously in one of your assignments. One of the things that you might have wanted was the absolute value of that of the first time we were doing the number guesser game, because you were going to tell how far off the number was. And so you can't really be -14 off, but you're going to be 14 off, whether you're 14 above or 14 below. So it gives you this absolute value here. Now let's talk about dead code. Let's talk about dead code, and then I'm going to write some more code for a little while. Right, so dead code is code that appears after a return statement in the same block of code. Right, so if it appears after a return statement in another condition, it's not dead. Right, but if you're in the same block of code and you have code after a return statement, what we call that dead code. Because that's code that will never be executed. Because whenever our program reaches that return statement, it's going to take whatever value it has, return it back up to wherever it needs it, and that's it. It's over. It's done. Anything after that return statement is not going to get executed. You'll actually get an error in Java where you'll get an unreachable statement error if part of your code is dead, which is one of the great things about our Java interpreter here, that it's going to help us out with that. But this is a dead code example here, where we've taken that absolute value method from the previous slide and just added a little print line to the end. So what's going to happen here is it's either going to return -1 times x or negative x to return the positive value of whatever number is less than 0, or it's going to return x. So one of these conditions here is going to return true, and it's going to return the value that's in there. And whenever it returns that value that's in there, it's done. It's finished. It's over. So it'll never get to the point where it prints out that last line. So what I'd like to do is I'd like to write another little method in our proof of concept code here before I start talking about more stuff. And this will be a get input method, right? So this will be a method that we'll use to get our user's input and return it back to us, which means we're going to need our scanner to do this. So let's get this ready by importing scanner. Import java.util.scanner. And you know what I'd also like to do with this is I would like to make this method private, which is going to be new and different for us. So in order to make something private, we're going to need to incorporate the use of objects after we make it private. Because of its privacy, you know, it's not letting other parts of the code be able to access it. You know, that's one of the things of the scope. So if we say, oh, this is a private method, then it can't be accessed by other parts of the code. With a public method, we can access it with any other part of the code. That's why we start out with just public methods, because we can call a public method from within another public method, or we can call a public method from within main, or we can do whatever we want with it. Because it's public, it's open, it's available. When we start to get into private stuff, then it's more hidden. And we have to start to use objects to be able to gain access to these different parts. So I'm going to create a new private method. So we're going to make a private integer method, because we're going to get the input that we want to check to see if it's even or odd. And we're going to call it get input. And we're going to give this an argument that's going to be a string message. So whatever the message value will be the line that we present to our user. And we can start to write this in much the same way that we would write anything else, but we have to do it just a little bit different. Because we need to declare our scanner object somewhere else. Because this is private now. So we're not going to be able to get our scanner in there and out of there. So I'm going to need to declare the scanner at the global level. Meaning I'm going to come up here to the tippy top above our main class or our main method. And I'm going to add public final. Make it unchangeable, you know, make it a constant, right? public final scanner in equals new scanner system.in. So this is basically the same scanner object statement that we've written several times over now, but there are a couple things different about it. Right? We've added these public and final keywords to it, which makes it different. And where it's located. It's now located on the global level. It's not in a particular method. So what's great about this is that not only can we use this in a private method, but we could also use it in multiple methods. We can use our same scanner class as long as we create a different object for each method that we're pulling it into. And so inside of our private method now, we're going to create an object. And we're going to create an object for our class, a class level object, because that's where we have everything located, right? That's what we're working with here. So our class is called main. So we need to create an object from our main class. And what this does is it's going to take our class and it's going to make a duplicate of it in memory so that it can have access to different parts of the code while still being private. So I'm going to make me an object here. Main. We'll give it a name like obj equals new main. And so we see this is very similar to like what we wrote for our scanner here, because this is an object declaration. Scanner in equals new scanner. Well, we're saying main name equals new main. So it looks pretty much exactly the same here. It's this object declaration. And so now with this object declaration, I can call on other things that are a part of this copied object in my memory. So I can say create a variable called int data. We can print the info, system.out.print message. So we can show our user that message. Then we can take the value of data and set it equal to our object name, obj, dot in, which is our scanner up here at the top, dot next int. Now we'll look at what happens if we don't do this in a minute. Like it'll just throw us an error. It'll break things for us. But then we can return data here. And so it'll return that. So now in our main method, we can do our system.out.print. We can even put it in a, we can take this and put it in a function even, or a variable rather. And we can say, int, or no, string outcome equals even, odd, get input, enter whole number. And then we can print outcome. Now you see something here. Right, we see something here. Get input has a red squiggly under it. Right? This will oopsie doopsie. It won't work, right? Like if we try to run this, we'll get a big error. And we can see that a non-static method Our non-static private method cannot be referenced from a static method. So what do we have to do? We have to create another object. And since these object names are scoped to the method, we can really just take this same statement here, copy it, paste it here, and then instead of get input, we're going to reference obj.getInput. And would you look at that? That little red squiggly went away. So now we can kind of use this more object-oriented programming approach to be able to run our program. Works like a charm. So what I'd like to do is I'd like to talk about just a few more slides, and then I'd like to come back here and do another quick program really quickly. We'll go ahead and make ourselves a REPL here. CSC 151 OL Sp21 toy car inventory. So I'd like to talk about a few more slides before we do that program. But I'm going to kind of go through them relatively quickly because I think we've already talked about pretty much all of these slides, just not directly with the slide in front of us. Beginners often make the mistake of writing a lot of code before they try to compile and run it. When you do this, you end up spending way too much time debugging your code. So there is a better way, and that way is kind of the way that we have been encouraging you to do things for a while now. It's this idea of incremental development. So we're going to start with a working program. And we're going to make small incremental changes. That's one of the reasons why I don't mind it that REPL gives you that system.out.println statement right off the jump. It's fine. Right? Because you're starting off at the core with a working program. And you can make small incremental changes to it from there. And so as you're making these incremental changes, you're testing. So as we write a method, we're testing that method. And we're going to write and test a method before we go on to the next method. And we're going to make these incremental changes because if we are chunking up our code into methods, separating things out into these, where each method has its own specific thing that it's supposed to do, and we chunk our code up into that, then when we test, we're testing a specific function, and if we find that it works, we can forget about it. We can say, okay, this function works. This method works. We don't have to go back to it. We've got it. We've got it right. And so that's one of the great parts of this incremental development plan. You know, because once you get a program that's working, then you can start to refactor. And maybe you could take code that maybe you wrote a little bit inefficiently and start to condense it down to make it more efficient. And so on and so forth, right? But ideally what we want to do is we want to start with something that works and then move into trying to make it better, which makes a whole lot of sense. Right? We want to wrap our brains around the problems before we try to work on a solution. So the first step is to consider what a like what this method should look like in Java. Whatever your method is, whatever your path to solving your problem is. What does that look like? How many methods might you need to solve your problem? What are the inputs, the parameters, the arguments that we're going to need? And what are the outputs or return values that you're going to need to get out of these functions? You're going to come into it with a plan. And it's really something that I've been kind of neglecting here in these live streams, is planning this stuff, because we have this limited amount of time in these live streams. And I want you all to, not have to sit here watching this forever, which, the way we've got it so far is long enough. In normal seated classes, what I might do is I might sit down and plan out a program before I start to write it with you all. And in that, I'm having to look at, well, what are all the functions that I'm going to need to solve this problem? I'm going to take the problem and break it down algorithmically, step by step, beginning to end. So then I can understand, okay, I'm going to need a function to do this. I'm going to need a method to do this. I'm going to need a method to do this. And then from there, I can start to determine other things, like what my arguments are going to be and what my returns are going to be. And so really the majority of the time, your programming journey should start on a piece of paper. Like, you're not necessarily writing code on a piece of paper. I would discourage writing code by hand, because you want it in an environment that you can test it with. But you do want to plan and try to make a plan for what you want your code to be. It's kind of like planning out a big essay you're going to write. If you know that you're going to write a big essay, and in order to write that essay, you're going to need a section on this and a section on that and a section on this other thing, you might sit down and you might make a plan of everything that you need to do. And it's the same thing for when we're planning out programs like that. And one of the things that we can use for this is we can use those stubs that we talked about earlier. And we saw those, so I'm not going to spend much time on those. A stub is just like a little placeholder. So it just gives you that method signature or that method header and a return statement like we were doing earlier. Makes it, something you can get to. So you can kind of put a plan out in your program without having errors return. But at the end of the day, one of the things that we want here is we want to test. We want to make sure that we're testing, and testing enough to make sure things that are working. And, we can use sample values if we have to make sure stuff works. And I think we'll take that approach as we look at this quick little sample program here. To wrap ourselves up today. Because what I want to do is, you can imagine for yourself that you've been hired by Santa Claus. This is a nicer one to do toward the end of winter, or toward the end of December. You can imagine that you've been hired by Santa Claus, or maybe Hot Wheels, since it's not close to Christmas. Christmas was, over 3 months ago. But we can imagine, if we will, we were hired by a toy car company. And this toy car company wants us to take an inventory of the cars, or rather of the car parts. And it wants to know how many cars can be made with the amount of parts on hand. So in order to do that, we need 1 car body, we need 4 car wheels, we need 2 car axles. So let's think about this, right? What do we need to, what kind of methods do we need to write? Well, we need to write one method that's going to get our input, right? So we need one method that's going to get input. And one method that's going to calculate how many cars. So our get input method, since we're using a value method, we can use that get input method multiple times to return different values for the different parts that we have. So what we'll want to do is we'll want to ask our user, how many bodies do you have? How many wheels do you have? How many axles do you have? And then we'll run it through some calculations in our how many cars method. And we will use that to determine how many cars we can build with the available parts. So we know we're going to need to use a get input method. So that's one of the things that we can do first here. We can write this get input method. And we can write it the exact same way that we just wrote that one on our proof of concept that we just did. So I'm going to import my scanner. Import java.util.scanner. And I'm going to create my scanner object at the class level. So that's going to be public final scanner I equals new scanner system.in. Remember that I is whatever we want to call it. We can call it I, we can call it N, we can call it user input, whatever we want to call it. And so now we can write that private function again. We can just write it the same way that we just wrote it in that other example that we just did. So that's private int get input. We'll add a message as a string argument. And see, that's the great thing about using our value methods like this, because I could take this thing that we just did, copy and paste it over, and it's the exact same. Since I'm not relying on any other method, since it's all kind of self-contained and modular, I can import it from one file into another file, or I can just copy and paste it from one file into another file, and then all I have to do to use it is invoke it. Easy peasy. So we'll add our object here, which is something that you might have to change based on what your class is called, right? So main obj equals new object or new main. Int data system.out.print, which is going to be our message. We're going to set data to the value of our object obj.i.next int. And then we're going to return that data value. Return data. So since we already knew how to write this function, I just wrote it from top to bottom. Ideally, we would start out with our stub and then go backwards. So before we test this out, let's go ahead and add our stub for our other function. And that'll just be we'll just make that a public function. Public static int cars. And we'll have 3 arguments here, one for the number of bodies, one for the number of axles, one for the number of wheels. So we'll have int b for bodies, int w for wheels, and int a for axles, let's say. And then we'll just complete the stub here. So return 0 for the time being, just so it doesn't throw us any errors when we're testing our other stuff. So now we can go into our main method and we can test this getInput method. So we can say system.out.println getInput, enter number. But remember, that's a private method, so we need to make an object here as well. So that's going to be main. We can call it something different if we want to, like main O equals new main. So now that'll be O dot getInput. So now what we can do here is we can just hit our run, test this out, just make sure our getInput function is working. So we should expect to see that enter number as a message to our user. We should be able to enter a number and then just have that number echoed back out to us. So if we run that, we get enter number the way we should expect. We can enter in a number like 12, and we get 12 back. So now we know, beyond a shadow of a doubt, that our getInput function is working. So we don't have to worry about that function anymore. We know if something happens to change things, to make errors, it's probably in this new function that we're going to be writing. So now I can get rid of this code here where I did my output, because it was just a sample. So let's write this other situation here. And this is actually going to be similar to an assignment that you all had to do in the past, to a lab you all had to do in the past, the whole finding the smallest number thing. Because that's essentially what we want. We want to take each of our values that we get in here. If they're one of the parts that needs multiple parts to build one car, we're going to have to divide it by how many parts that needs to build one car. And then we can check with our numbers to see what our smallest number is between the three. So we have our wheels and our axles. That require more than one. To build our car. You know, for example, our wheels are 4. So I can say int WT for wheel total equals W divided by 4. And then I can say int AT for axle total equals axles A divided by 2. And so that gives me the total amount of cars that I could make with the wheels that I have on hand, and the total amount of cars that I can make with the axles that I have on hand. But the bodies are going to be kind of crucial as well. In fact, our bodies are going to be the most crucial part. Because you kind of got to have a body, but it also matters that if you have 7 bodies but enough wheels to only do 6 cars, that's going to limit as well. So whichever of these numbers is the smallest, so we're going to use that math.min function to find out how many cars that we can build, and then everything left over is going to be spare parts, because you can't build a full car with them. So we can say total equals math.min, and we can even use math.min b comma wt. Actually, what I would want to do here, math.min b comma wt comma AT. So it's going to find the smaller number between the bodies and the wheel total and then find the smaller number between the smaller number of those two and the axle total. And so then from here we can return our total cars. Now before we put these together, we want to test them separately. So I'm going to print out this method. So we called that cars. And I'm going to say we have 6 bodies, 12 wheels, and 5 axles. So in this case, our wheels are the limiting factor. So we should expect a 3 to be our output here. Oops, what did we forget? Cannot find symbol, return total. We forgot to make that an integer. We forgot to give that a type. Whoopsie doodle. See, we tested it. We found something that we missed. And we get 2. Which is not what we should expect. Which is a little strange. Oh, you know what? It is what we should expect. I'm doing math poorly. Because we need 2 axles for each car. So we can only make 2 cars with the amount of axles that we have here. If we upped this to like 7, then we should have 3. There we go. So it works. It works. So now we can just take these 3 functions, or we can take these 2 functions, put them together, utilizing our main method. And so we would just do something like int num wheels equals o.get input, enter number of wheels. Oops, that's not. Wait, yeah, that's what we want to do. Thought for a minute I was programming in a different language there. I'm sorry. Too many programming languages in one semester. Int num bodies o.get input, enter number of bodies. So each time it's going to run that get input function. It's going to take the return value, put it back into this variable here. Int num axles equals o.get input, enter number of axles, int total cars equals cars. And we're doing bodies, so it's num bodies, num wheels, num axles. And all we have to say now in our print statement is the total number of cars that can be made with parts on hand, colon space, and concatenate that with the value of total cars. And there we have it. A functioning program. So we can put in something like, oh, let's run this and test it. Inner number of wheels, let's say we have, well, I don't know, let's say we have 26 wheels. Inner number of bodies, let's say we have 11 bodies. Inner number of axles, let's say we have 18. Now let's make it more. Let's make it like 21 axles. Right, so now let's do our math. 26 divided by 4, well, that gives us 6 with a remainder. So we can make 6 cars with the wheels that we have on hand. We can make 11 cars with the bodies that we have on hand. We can make 10 cars with a remainder with the axles that we have on hand. So in this case, our limiting factor is our wheels. So we should be able to make 6 cars out of our parts on hand. The total number of cars that can be made with parts on hand is 6. Beautiful, beautiful, beautiful. You know, from here, right, like we could add a little title to this to jazz it up a little bit. Whatever we want to do. But this is a functional program. So from here, we can take this simple program, and you can see how simple it is, right? Like, only 40 lines on the screen, and that's with a lot of blank spaces. But with that being said, that's where I'm going to stop for today. I'm going to turn on the music again for just a minute, hang out in the chat for just a minute or two, in case anybody here is live with me and has any questions. And if you're watching this later and you have some questions, please feel free to contact me. But as always, thank you for watching, and we'll see you next time.
Yeah.